Hello everyone. So today we will talk about machine learning. Last time we have talked about data science, right? And any of you here, do you remember the concept of data science? I told you as it's simple as the combination of two things, right? The first one, what is D and what's EM? Everyone, do you remember from last lectures? We talked, uh, we have give you the concept of data science, and if we simplify the concept, it will be the combination of D and M. So what is D and M, everyone? Every math? No, no way. It's not. Yes, home. That's correct. Thank you. So that's a data and machine learning. So last time we already talked about data, right? We talked about text, tabular data, sound, image. Okay, now we talk about the other part, the machine learning. Oh, and that is just a required reminder. This quick tutorial you will do still another in-class quiz. Just like last time, you come into the class, you sign the checklist, and then you will do the quiz. And I also have some sample questions for this time. Okay, now test your mind. The first wave of AI were characterized by A. Lack of breakthrough, B. Unrealistic expectations, C. A successful demonstration of strong AI, and D. Caution pessimism. Pessimism. So A, B, C, D, everyone. One student select B, B. Okay, many students select B. Excellent, you got XD. Yes. Next one, check. Okay, so this one I think you don't know because it's in in the slide in this which like. So which algorithm is used for anomaly detection? Okay, and you will see the answer soon. But here I just show you that's in the last two one. Okay. So in this quick lectures, we will cover two things. The first one, machine learning. And in machine learning, we have the thing that's called deep learning. It is about the neural network, right? We will give you the rough idea what is it about, why it's so good, it works so well nowadays. Okay, and this see, okay, I think and he talking about this one, right? Yeah, that's in the and this part, everyone, I think it's very, very useful in two aspects. The first one, if you continue to study in the AI path, then for sure you need to uh, know about the concept. The concept I will mention, supervised learning, unsupervised learning, label data, feature, something like that. You have to know them in order to continue to study. And for the student who want to apply for the job in this field, I used to have some student before, and they told me that when they apply for the AI position, I think that's a junior position, and in that interview, the interviewer asked them some questions, and thankfully, they say they already learned these lectures and they remember what have told in these lectures, so they can answer that uh, well. Like they asked him they are building some some model. And what is that model? Is that supervised learning or unsupervised learning? Something like that. And they can answer as well because they have learned this one. So you can see it's kind of even affects your future career, right? It's just some example. Okay, so now let's go into the detail. Now we will learn several concepts around the machine learning and um, to be honest, they are very fundamental. It's actually fundamental, essential. If you told that you already learn about AI, at least you should know about them. Otherwise, when in the future, when you listen to someone talking about AI to machine learning, then you will have no idea. If you understand about the concept, then next time when you read even the AI book, you can feel familiar. It can help you to learn things better. Okay, so here's the outline for today lectures. The first one, I will talk a little bit about assignment two. It's already open, right? So I think now you can already see all the detail on the canvas. Next, we talk about some definition in machine learning and types of machine learning. And the next one, the neural network. If we still have time, we can roughly talk about the idea of neural network. Okay, assignment two. Let me open the canvas. So I think you can now see the full description of the assignment now. And here, when you, the important thing you should know about this assessment, first is that it's the group assessment. And I think you make it, you already have a group, all the students have the team already, right? Okay, so 0 student don't have any team, and all the students have the team already. And for the team with less than 4 students, they already contact the um, the tutor, and we actually will resolve it. Um, okay. The next one, the weighting is will be 40%. And in this assessment, you need to submit uh, 2 things. The slides. Actually, that's 3 things. The slides, the recording, your reports. I forgot to type it in the report first. The slide presentation and the recording. So the deadline to submit them will be week 9, right? So this week is week 4, beginning of week 4. So to week 9, we have about more than a month, right? That's 5 weeks from now. And because you will need to do the presentation, so we don't accept the late submission because you need to present it online, right? So you need to submit uh, before the scheduled time for the presentation, and the presentation will be happen in week 10. So all the students need to be submit in week 9, except if uh, we have other chance, then we will announce. Otherwise, just stick to this deadline, everyone. And your team will present in week 10 at your tutorial sections, and the tutor will provide you with the schedule. So each team need to be online for their time slot. They don't need to attend for the whole sections, and this will be online, right? Because it can longer than the section in class. So we cannot book the room for longer than that time. So it will be held online, and you will see the schedule by the tutor before week 10. So all the information is here, everyone, but the key part you need to focus is this one, assessment task. Click on this and you will see all the details of this assignment. And here data set, you will need to build a model using this data set, and then you will write a report. Okay, how to build a model, the AI model using data set. That's the content of next week, right? The next week in both lectures and tutorial, we will talk about how to build your machine learning model using your own data. Okay, and all the steps there, you just follow all the step we show you, then you can build a model. And the tool So you can use the no code tool. We give you the instruction, the very detailed instruction step by step in the no code tool. That's in the AWS. That's why you see the AWS invitation email now. But for the IT student, you also have the option to use the coding tool. We also have some instruction on that for you, but it's your choice. You can select no code tool, no coding at all, or you can also select programming tool to do this assignment. And we give instruction on both tools for you, okay, with the detailed step by step. So no worry if you have no idea before. This is for you, okay? This is for the student with no idea before. And this is the data description. You will soon know what is it about, what does it mean. Um, okay, and you need to submit the report and also the presentation talking about these things. Okay, describe the problem, explore the data. How to explore the data? We will show you step by step. Analyze the model performance. We also show you that next week, and write the recommendations on that. And we also prepare the templates for you. You did templates, then you can fill in all the things here in the detail. And the report limitation is 3,000 words. And by the end of the report, you include a contribution form because that's a group work, right? So that's about the reports. Then you need to prepare the presentation, and it's 10 minutes for each group. So imagine that you need to report to the CEO, I mentioned here, for imagining company. And each team need to report and submit their recording. Uh, so you don't present live at that time. You will record it. And then at the time of presentation, your team, one student, will play the recording. Okay. You submit the recording and then you also play the recording for the maximum of 10 minutes. Everything after 10 minutes will not be rated. Okay, so some students may ask why don't you allow it to do the live presentation? Actually, the recorded presentation is the one type of professional presentation. You will see that happen in many um, reputational conference. They do that for the VIP people. Okay, professional because with the pre-recorded um, presentation. It can ensure the quality. Okay, and get used to this when you do the capstone project. You will do similar thing. You need to present it, record it, and then you will show it in the presentation day. Okay, and after the presentation, uh, the the tutor can also ask questions. Okay, so you only need to show at your time slot. Okay, you will see that your time slot it can be 15 to 20 minutes as maximum. Okay, 10 minutes for you to play the recording, and the rest of the time will for Q&A if they do have any questions. Okay, and as submission instruction, you need to submit 3 files at least, the report, the presentation slide, and the recording. It can be the link or the file. Uh, Less than 1 gigabyte or something, I can't remember exactly. Yeah, from there is a limitation from the canvas. If you cannot submit it, then you can submit it on YouTube or any drive, and then you can play it. And if you use AI, please follow this instruction. You need to cite this properly. Without it, it will be considered as plagiarism. That's a big issue, right? Academic integrity, right? So if you use AI, you're allowed to use it, okay? But you need to cite properly. Here's the way, okay? For example, if you follow the citation, APA citation, this is in-text citation, and this is a reference list. You give something like this one, okay? And for more detail, you look at this one. If you don't like APA, you want to use IEEE, you can use it. See it here, okay? And also, it's your responsibility to explain all the text that your team submits That means you need to at least understand all the things you read in the report. If we do have any questions, then we can ask you and you need to explain it, right? Okay, so that's about the assignment 2. Any questions, everyone? Type 0 if you don't have questions at the moment. Okay, that's good. Thank you, everyone. Now let's go to the lecture's contents. Definition of machine learning. So machine learning is a broad field, so we have several different definitions. Let's talk about two well-known definitions. The first one from the AI pioneer Samuel. I think you see his name in the first wave of AI, right? In the first wave of AI, he's here in the first wave of AI, Samuel, one of considered AI pioneer. And in one of his article published in this year, he mentioned that machine learning is the field of study that gives machines ability to learn from experience without being explicitly programmed. So the key point in this definition is this one. I make it in bold without being explicit program. What does it mean? So compared to traditional coding, if you're from IT, so this one I learned a little bit for IT student. So in IT, if you want the machine to solve some case, then you can write something the if statement. If something happened, then do something. Uh, if some other things happen, then do something like that. Okay. So this called explicit program. You need to list all the case, but when the program it run in real environments and it see not case S1, S2, but it see case S3. So for some explicit programs, it will fail to run, right? Because you don't know. You tell me only S1, S2, why you ask me S3? I don't know what to do. So it's called explicit program. But machine learning is another approach, everyone. Even when you do the training, you will see soon. Like I train it, so for 1,000 cases of housing price. But when I use it, I ask it to predict for me the price of the house for another case outside of that 100 cases. It can still answer me. So it can actually learn from experience. You will soon know experience is actually the data, right? It can learn from the data. It can generalize the knowledge from the data. So you don't need to tell it uh, like all single cases. You need to give it the data and it will learn the insights. Okay. So that's the difference from machine learning and traditional computing program. And one first example of machine learning programs is the checker program. And in this one, I don't really know about this one, but some students tell me that this, this game in Vietnamese is called cờ gánh, isn't it? I don't really know. Okay, but it's that's the types of chessboard, and in this game, Samuel, he's not a good player. He's not a good player in this game. However, by the way he programmed this game, it actually plays better than him. So it's an evidence of not being explicitly programmed because if he want this one to be good, then he need to be that's good, right? Like for example, it need to do well in 100 cases. Then he need to know about 100 cases. But he's not a good player in checkers, like he only know about 50 cases. But this program can play better than that. So it's a side of this program is not been a implicit program. Here is another look more formal definition from Mitchell in his book. Uh, he mentioned a computer program is said to be learned, is that it can learn from experience E if it can perform some task D better and better if when it sees more experience. Okay, I would like to repeat. A computer program is set to learn from experience E if it can do the task D better and better when it sees more experience. Okay, when it sees more experience, it can do better. But the question is that how you can tell is it better or not, right? Let's say you have two programs that's like chess. Let's say program A and program B. How can you tell program A is better than program B? Now we need a thing that's called performance measure. Just like the mark in uh, in uh, in 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 college, right? We will say student A perform better than student B, usually because student A had a higher score than student B. It's just an example, right? So in machine learning, we do have the thing that's called performance measure, and we're using that performance measure to tell if program A is better than model A is better than model B or not. Okay. So in this definition, we have three terms. The first one, experience, is actually the data you gave to the model, and we have the task. So that's it, what you want to do, right? Let's say you want to train the program to play chess. So the task is playing chess. If you want to train an AI model to filter the spam email, then the task will be spam filtering. Okay, so that the task is what you want it to do. And the last one, performance measure, is the measure of the performance. That's it, right? Let's say you, in order to measure uh, performance of A and B in playing chess, then you can count the number of win game by each program. Let's say program A is wins uh, 20 games, program B is win 5 games. Then we, based on this performance measure, we can say program A, sorry, model A is better than model B. Okay. However, if we change the performance measure, then the answer can be different. Let's say now we told you this performance, but we use another performance measure. Let's say uh, we will compute the rate of winning. That means I will count the number of win games and I will divide it by the total of games. This one is look more reasonable, right? Let's say 8 is win 20 game, but it's already played 100 game. So its winning rate will be 20%, right? But program base it wins 5 game, but it's only just played 10 game, so the winning rate will be 50%. So in this case, we say program uh, model B will be better than model A. So you can see how performance measure is important to measure the performance of the model, right? You change the performance measure, then your answer will be different. Like if we select performance measure one, then we select model A. But if we select the performance measure two, then we select model B, right? So that's about performance measure. Now let's see some example. Okay, so now let's read this one, everyone. I just put here again the definition for you for your reference. Now let's check this the MCQ. An AI powered coding assistant analyze millions of uh, code. It helps software engineers by suggesting code completions and even generating entire functions. So what is task T in this setting? A task T will be about analyzing existing code by task T will be reviewing the code, provide feedback. Task D will be about generating code snippets. Task D will be the number of lines of code produced per hour. Okay, so A, B, C, D, everyone. Select your answer. What is task D in this description? No, it's not multiple answer, Hui. It's only one single option is correct. C, B, and another student select C. Okay, so you can see here they are on the action, right? Analyzing, reviewing, generating. This one is not action. So this is on the action. But the task we focus here is generating the code, right? So C will be the correct answer. So what is A, everyone? What is A? We have three words here, right? Oops. We have experience E, task T, and P is the performance measure. So what is A, everyone? Yes, A is actually experience. So it will analyze this code to get some experience, right? So it's actually the data you give to the model. So it's a experience. Yeah. And so what is P, everyone? Performance measure? Yes, that's correct. It's D, right? This one can be used as one performance measure, but it's not the unique one, right? Another example, okay? A food tech company uses AI system to develop new plant-based meat alternatives that are good for both environment and human health. The AI model takes it as input 1,000 of ingredients combinations and processing parameters, constantly refining recipes to mimic the taste and textures of meat. What can be the performance measure in this setting? Okay, A. The AWS health rating start would give food products rating from 0.1 0.5, this is 1 over to 0.5 star or 5 star. So 5 star for the best food, like the healthiest food, and 0.5 star maybe some fast food or something. B. Sensory evaluation score texture taste given by human panelists. C. The number of ingredient combination and processing parameters. D. B, A and B. So which one, everyone? What can be the performance measure? Okay, three students answer D. How about other student? Any other choice? Okay, so in this case, it depends on um, your requirement, right? And if you check here, you want it to be, what is it? To improve the taste and the texture of the meat, right? So this one for sure will be one performance measure, right? But the other one, you can see here, they want to develop good for environment and human health, right? So it's actually a also a performance measure because you want that, right? You want that, so you need to measure that. So A and B. But here we still meet the other one environments. Maybe we need to have another performance measure of that. Okay. So it depends on your problem. It depends on your expectation, and we select the proper performance measure. But if we just want this one, we don't care for the health. We just want it to be very tasty. Then maybe only B will be the performance measure, right? On the other side, we making food for some patient want to recover from some disease. Then we don't care for the taste, but now we only care for the health. Then B will be the only performance measure. Okay, so it depends on your requirement. Now let's talk more detail, more concepts, training data. You will see soon we have the data in the form of table like this one. Last time we call that tabular data, right? And tabular data is one of the most effective types of data to be processed, and it's still one of the most common one in the system we do have nowadays. When we training the machine learning model. So in in training data, we may have many rows and many columns. The whole thing in this one, the whole table you put into training the model, we call it training data. Okay, or sometimes we call it the training set. So training sets or training data is one thing. Now for each row in machine learning terminology, we call each row here sample. So keep in mind this one. I think we already learned about that last time, right? So we call this sample one. This is sample two. This is sample three. So each row will be a sample, right? The other name is data point in some other book or some material. They call it data point or they call it instance. So they are intangible. You can use them interchangeable. So sample, so data point instance just about a row in your table. And for each column here, we call it features, or sometimes we call it attributes. So attributes or features, the same thing. Let's say you want to predict the housing price. You will see that we will do a project in that in next week. We need to collect the data like the number of the room in the house, the areas of the house, the years of building, and address or something. Okay, and also the price of the house. So this column we call the features. Okay, but now it is important. If we do the types of supervised learning, you will know soon what is supervised learning. Among these features, among these column, we will have a special column. It's called label. Okay, so label is also a column, but it is about the output of the model. Let's say you want the model to predict the price of the house, then this column you call it label. So label will be about the output and other features will be the input for your model, right? You want to predict the price, so price column will be the label. In other problem, now you want to predict the number of area. Let's say you have some amount of money, 3 billion, something like that. Now you ask yourself, or you want the model to give you some estimation how large the house I can get. Okay, trend uh, 50 square meter or 90 square meter. So now you want to predict the area. Now you want the model to output the area. So at this time, the area will be the label. And other columns, you will call it feature. Okay, it's clear, right? And performance measure, we do have a lot of performance measure, just like in this example. It depends on and your problem. Like let's say I want to predict the price, so I can measure it like the average, uh, like average error for my prediction. And here is the name of the performance measure we do have in machine learning popular one. You will you will see a few of them in our hand-on projects. For the other one, you can also check online whenever you want to use it. And depending on the task, you will should know what are they. We will talk about them later. Um, but depends on the task. Depends on your requirement. You will have different performance measure. Like one thing is called root means where error is short for RMSE. Or we have another performance measure is called mean absolute error, MAE. And we have another performance measure is called R square, R2 score. Okay. For classification, we have performance measure like accuracy. This one is quite intuitive. How accurate it is. So we call accuracy. Like you predict 1,000 image. How correct of how is your correct rate? We call that accuracy. Let's say in 1,000 image and you predict correctly 900 image. So your accuracy will be 90%, right? So we call that accuracy. F1 score in another performance measure for classification. We don't go to the details of the definitions here. I just want to show you that we do have many performance measure. Now let's talk about the types of machine learning. Machine learning is a broad field. So in order to give you an overview of the field, or in order to classify on the algorithm, categorize on the algorithm in the field, we need some way to to classify them, right? And one way to that is to talk about the types of the task. And in machine learning, we have different types of machine learning. We call supervised learning, unsupervised learning, and reinforcement learning. We do have other ones. Sometimes you may heard about semi-supervised learning or one-shot learning, something like that. We don't talk about all of them here, but we will talk about three most common types of machine learning. That is supervised learning, unsupervised learning, and reinforcement learning. If you understand about the idea of the three types of machine learning, then you read about the other types like semi-supervised, zero or one-shot supervised, one-shot learning, then you can get the idea very quickly. So these are the foundations. Supervised learning is simply about using the label when you training the model. Okay. So in supervised learning, you give the model with the data which include the label. So we call that label data. That's it. The data have label inside. Let's say you want to predict the housing price, then in your table, in your data, you do have a column that's called the price of the house. So this is the label you want to predict, right? And you also provide it into the model to train it. Then we call this type of machine learning is supervised learning. It's learning under supervision. We gave it some knowledge, right? In other case, you want to predict the price. However, in your data set for training, you don't have the price. You don't give it the price. Then it's called unsupervised learning. You will see it soon, right? So it's clear, right? Supervised learning is when you give the model the label, and unsupervised when you don't give it label. Right? And in supervised learning, we have several subtasks. The first task is called classification. Let's say you want to classify in email is spam or not spam, or you want to classify an image. Uh, this is the image of a cat, a dog, the image of the classroom, or something like that. So we call that task classification. There's some example, email classification or image classification. You are given an image and you will tell what is this image about. Okay. So you look at this one, you will know this one is image of a cat. Okay. You give another image and you want to ask the model what is it about. Okay. And this is actually image of a dog. right? So this task we call classification. And actually the columns here is the label, right? The image, you can consider this one is the features and this one is the label. For each image here, we will tell to the machine what is it about. So this is an image of the airplane, this image of automobile, this image of birth. So these things here is the outputs we want, and we also give it to the model when it trained. So we call this a supervised learning, right? And here you can see an example of image classification with the label like airplane, birth, cat, deer, dog. Okay. Another example, sorry, another task we do in supervised learning is called regression. Okay, so regression and classification, they are the same in the way they use the training data. That is, they all use the label data or the data with label. So that's where the regression and classification are the same, right? But they are also different. So the label in classification is will be the street number. Let's say you will classify the spam email at 0 and not spam is uh, 1. Right? For image classification, you can also put a number for this one, like airplane, you will call it class number 1, class number 2, class 3, class 4, class 5, something like that. So the label in classification is a discrete number, it is a whole number, right? You don't need you will never need to predict if image is 5.4 or 3.7, something that you don't have this output. Your output is always 1, 2, 3, 4, 5. So we call that classification when the label is the whole number, right? But in regression, we have continuous value in the label, okay? Continuous. Let's say you predict the housing price, so it can be 1.7 billion or 1.71 billion or 1.705 billion, something like that. So you cannot count on the values it can output, right? Here you can count. So we have here only 10 class. You can count, right? It's countable, but here is not countable. Is meant in another concept, everyone. But here I mean you cannot list them all, right? You cannot list them all. Now let's talk about weather forecast. I have a question for you here, everyone. So, in your opinions, do you think weather forecast is a classification or regression? Which one, everyone? So, my questions again: weather forecast, is it classification problem or B regression? Type A if you think is a classification. Type B if you think is a regression problem. Now test your understanding. Okay, my students say B. Many students say B. Are you sure? Many of you say B because you see it here, right? It can be both A and B. It depends on the label against everyone. For example, if I only want to predict a day is a cloudy day, a sunny day, uh, a rainy day, something like that. So my labels is just rainy, sunny, cloudy, and I can put a number for this, like number 1, number 2, number 3. I don't need to predict anything in between. I don't need to predict 1.5 or 2.4, something like that. So if I formulate my problem like that, then weather forecast is will be classification, right? Because the label is the digit number. So in order to answer if the problem is classification regression, you need to look at the actual data, right? But on the other hand, if you want to predict like the temperatures. Let's say it can be 32 or 32.5, 31.0 or 31.7, something like that. Then it will become regression, right? Is it clear, everyone? Type E if you think it's clear and no N for not clear. Y, I mean Y to Y if you think it's clear. Okay, thank you. So in order to answer a problem is classification or regression, you need to look at the table, the label. If it's a continuous, then it's classification, and discrete, then it's classification. And here is some important supervised learning algorithm, and they can use for some of them can use for classification, some of them can use for regression, and some of them can use for both. Let's say these things they can be used for both classification and regression. This one is used for classification, and but they do also have some version can do regression, right? But linear regression, very clear, this is regression, right? But logistic regression is actually the name is can confuse you. This one is actually classification algorithm. Okay, this is some examples, some name. In the future, if you study machine learning course, then you will see them. Now let's go to the next uh, types of learning, unsupervised learning. In unsupervised learning, in contrast with supervised learning, in unsupervised learning, we don't use the data. So we call it unlabeled data. That is no label. Okay. And in unsupervised learning, we also have several tasks. The first one is called clustering. So clustering is the task of grouping many samples into one group. Okay. Let's say a bank. It gives you many transactions record of their customer of the customer, and they ask you to group similar customer into one group. Let's say they want to group number one, group number two. So group number one is the saving group. So these the customer they usually uh, open the saving account, and this one is like loaning group. They usually loan money, something like that. So the bank can have different marketing strategy for different group of the customer. So we conduct a task clustering. And in this way, when the bank gives you the data, you cannot see a column that tell the types of the customer. Like the customer, they don't have to the bank that they refer saving or they refer making loan or something. They don't tell it. So you don't have that column. That means you don't have the label, right? You don't have the output you want. So it is actually unsupervised learning. And the task you are doing is called clustering. Clustering is about grouping, clustering sample together automatically. And here is some algorithm name. K-means, DB scan, XCA. Okay, just to give you the name. Okay? Here is an example of new clustering. So let's say on the internet one day there are thousand or more than that number of news, and with the news publishers they don't give any talk for their news. They don't tell, oh, I'm talking about problem A, I'm talking about issue A, issue B. They don't talk about the topic. Okay, but in the content, when you read the content you can say, oh, they are talking about physics or something. Then um, Google News, Google News is actually using clustering algorithm to grouping the new of the same topic together. Let's say in this topic, um, I mentioned like when the muscle work out as neuron to grow. Okay, I really like it, this one. That means when you do exercise, you become smarter. Yes, it is. is actually. And so this is a recent research, but before that, I read from Harvard. They do have a very big research. It's lasts for 70 years. Maybe some psychology student you do know about this one. And that research that's a long time one, and they get so many valuable results. And one of that I still remember. They mentioned the kids, the children who do the housework, the house chore in their childhood, they have a higher rate to become successful in the future. Okay, because now we can explain when they do the house chore, they support their parents. Actually, they improve their brain activity. Okay, and you can see here on this new they talking about the same things, right? So that's called new clustering. Even those publishers, they don't have any talk for that. Another one, Einstein theory of general relativity face challenge. Okay, so that's another new clustering. Another example of uh, clustering is social network analysis. Let's say Facebook, when they want to target some advertisement. How can you know which group of people will interested in that advertisement? Okay, so before sending out the advertisement, they need to group the the Facebook user into different groups. Let's say this is a group about the people who really like technical news. This is about the people who really uh, interested in healthcare. This is about the people interested in economy, something like that. So when they have advertisement is about technical, then it will show up in this group, and it will be more likely this will get the the interest of these group rather than put in this one, right? So this kind of social analysis. And once again, um, the Facebook user, they don't tell to meet a company. I prefer in tech, or I prefer in healthcare, or something that they don't tell it, but based on their activity and the plot, it will automatically group them on together. Okay, that's why, for example, you IT student and you don't do any research on the buying a new laptop. However, in your friend circle, many students maybe at the beginning of the year they do research for the laptop, research for new type of laptop or something like that, and it will automatically appear in your one, right? Because you are in the same group with your friend who are also interested in the laptop, something like that. Market segmentation is an example about the bank when it groups different uh, types of customer, like I told you before. So that's an example of of market segmentation. Okay, another types of super, supervised learning is anomaly detection. Let's say in the product line, like your products uh, mobile phone, smartphone, right? And you need to do the QA check, right? Quality assurance check. And after that check, you need to classify this phone is okay or this phone have some issue, and you will eliminate it, right? With the good phone, then you will put it into the market. So in this one, we call the task of detecting uh, the the phones with issue is anomaly detection. So we detect anomaly, right? We detect the thing that's strange. We detect the outlier, right? And I have a question for you, everyone. Can we do? Can we use classification for this task? If you can answer these questions, then I think you understand what we are talking so far very clear. Again, I want to know which font is a good font and which font is a font Which issue? Can I use classification algorithm for this one, for this purpose, for this problem? So you type 1 for yes and 0 for no. Okay, let's check your understanding. 1, 2 students say 1, 3. Okay, so uh, oh, I see. All of the students who answer say 1. So can any of you tell me how can you solve it using classification in a little bit more detail? Imagine you get this problem from somebody, how you can formulate a problem and solve it using classification.
I can give it a try.
Yeah,
Can you hear me?
yes, I
Okay.
can hear you.
So if I understand it correctly, I was thinking like, so if we take the phone example, that you could say like, I want the phone to, for example, have a lot of data, or I want it to have a good camera, and then you classify the phones that you read about based on, okay, how many pixels does it have, or all of these features. Is that what you mean?
Yeah, and why is the classification problem?
Could you explain that?
Because the way um, you mentioned that you will have the camera, something like that, to capture the phone image to detect any defects happen on the surface of the phone, right? So why do you think it's
Mhm.
classification problem? Because classification problem is the supervised problem. So what is the label?
In this case, um, um, I'm a bit confused. So
Okay.
there is, sorry,
Okay.
there is, um, so you just said, you take, for example, the camera, you try it out, and then you see uh whether it like meets your expectations, and then you ask why is that a classification problem?
Yeah.
I'm really unsure, sorry.
Okay. Yeah. That's a good try. Okay, everyone. So when you so are you from IT or other major?
No, I'm not at all. Not at
Psych,
all. I'm new because
you psychology student?
no, I'm an exchange student, but in
Ah,
my
okay.
home university, I do sustainability sciences.
Ah, okay. Yeah, that's very good. How about other as the student you want to give it a try, or any student going to give it a try to formulate a problem here and tell me is it fit into the task of classification or not? Okay, so Bao things can fit to. Can you explain it a little bit further?
Yes, hello, can you hear me?
Yes.
So I think we have, in your case, for example, like we classify phones, we have like a very clear indication of if what a phone, like a good phone can look like as in it has no error. So for example, maybe during the quality check, if we use just a plain camera, we can say, for example, see that there may be scratches, like imperfections in back the back case, or we can see if, for example, there are other defects that, when compared to the reference good phone that maybe the model is trained on, it doesn't it doesn't look right to the model. So I guess it can be like a classification model. I'm not sure. But
Okay.
I think the main reason is just we have concrete information to classify it.
Okay. Thank you. Are you from IT? Which of your major?
Yes, I am from IT,
Okay.
enterprise system development.
Okay. Very good. Okay. Thank you so much for both of you. That's very good try. Uh, if it's your first time learning machine learning, so that's so good because you don't have any background so far, right? So now I will explain to you. When you want to tell if the problem is classification, it's important to tell if a problem is classification or clustering or regression. You need to tell what type of it because after that, you will select the algorithm, right? If it's classification, then you use classification model. If it's clustering, then you use clustering algorithm. If it's anomaly detection, you will use anomaly detection algorithm, right? You need to know which type of the task is that, right? You have to know about that. So the way to tell your problem belong to which types is look at the data. Let's say you collect the data, it have many features uh, like your friend mentioned the number of pixel, dead pixel, something like that, or the time of the screen on, or the energy of consume for 1 minute or something like that. So you have some indicator, right? You have some indicator, any indicator for H4, and also the image, something like that. The important thing is that you look at this table, is this data, and you check if is there any column that shows the outputs you want. Okay. So if you see one column is say the quality of the fonts like 0 for bad and 1 for good font, you have something like this. Okay. So this problem is can consider as classification because they you do have the label, right? And the label is the street number, right? But if you look at your table and you don't see this column, because in order to have the column, you need to hire an expert to examine the font for you, for example. And it costs a lot, so the company don't want it. They don't want to hire someone to do classify 0, 0, 1, 1. They don't want to hire some people like that. So you don't have the that column. So in case you don't have the column, you only have the features, then that problem is a unsupervised, right? And it will fall into the things that we call anomaly detection because we need to detect um, the rare case in your population, right? So for one problem, you can formulate it as classification or anomaly detections. It depends on the way you collect the data, right? And one other issue, even you can collect this data 0, 0, 1. However, you can see that in a dark light, let's say you produce 1,000 fonts. I think only a few fonts, maybe up to 5 fonts is the fonts have the issue, right? So you look at your data and you see 1, 1, 1, 1, 1. Only a few places you see 0, right? So the number of the class 0 is so rare. It's not enough for the classification algorithm to learn. Even you do have the label here, but it's too few. So you cannot use classification for that. It's not work well because you don't have enough data for the font case, right? For the normal case, you do have a lot, but for the font case, you don't have a lot. So classification is not a good choice. To do classification, you need to know, you need to have enough sample for on the class 0 and class 1. All of them need to have enough samples. For example, at least a few hundred samples for each class, right? But if you don't have that type, anomaly detection can help you with that, right? So in anomaly detection, it do not require you to provide it with the label. It will automatically tell you the anomalies or the outlier from the data. Let's look at this one. If you plot out on the indicator of the font into the chart, you can see something like this. On the font, on the normal font is maybe, for example, with the energy like this one is will have the temperature like this. With the energy like this, it will have a temperature like this one. So you can see most of our population will go into this area, right? But you have one font is have very high temperatures with the same energy, right? So this is anomaly, and anomaly detection is can automatically do that by grouping the normal font together, and any samples that far away from this area is will call the normal area. Anything is far away from the normal area is will consider as anomaly. So that's very effective for the task. Like when you do the QC, you don't have enough data for the man function font, right? So that's called anomaly detection. You don't need to provide the label is the good or not. It will automatically group the majority, and everything far away from the majority distribution. This will be considered as anomaly, right? Is it clear? I think it's okay, right? Another task is called dimensionality reduction and association rule learning. We don't go to the details here. I just want to mention you that in unsupervised learning we have several tasks to do like that. Dimensionality reduction is the task is about, for example, you have a very big data set. It have thousand of columns, and if you want to train a model with so many columns, it will be expensive, like it take a lot of resource to train, for example. So dimensional reduction is will automatically remove for you the column that is not good, not an accessory for training the model, not improve the performance. So it will automatically remove it for you. So we call the task a dimensionality reduction, reduce the number of the column in your data. And association rules learning, like in the supermarket, um, they need to they need to design the layout, right? Uh, and the vegetable area, it should put next to other food area, or it can put next to the domestic area, or it need to put next to the beverage. Um, so in order to decide the area, the layout of the market, I'm talking one example. We need to find out the rules of buying thing. Let's say someone who come into the market and he buys some vegetable. So it's very likely the next thing, the next item he will buy is uh, some uh, some spices or some milk or something like that. So we put those areas close together to make it more convenient for the customer, right? So that's one example of association rules learning. We find the rules of things happen in the data. Okay. And here is some example of the algorithm you can use in that. The last one, reinforcement learning. So the idea, I think you already know in tutorial number one, and is a very promising types of algorithm. It many people, many data scientists, they have a belief that this one can open the door to the thing we call AGI, right? I think you all know about this one, right? Any student here tell me what is AGI? Do you still remember? Or you can type 1 if you know what is AGI and type 0 if you don't know it. So if you many students type 0, then I will spell it clearly. Okay, that's very good. Artificial general intelligence, right? So AGI is the single model that can learn everything Just like human, we are kind of general intelligence. If you study IT, then you can do programming. If you study painting, you can do painting. If you study writing, then you can do writing, right? Of course, some people will do better than the other ones. It depends on many things, but at least you can do it with your our body and mind, right? With your single model hardware and software, you can learn different subjects, and we call that general intelligence. And at the moment, we don't have any such model, right? Because each model it can only learn the thing it's designed for. That's why we call that narrow AI. And in reinforcement learning, we give the AI model the ability to discover things by itself. You don't need to provide it with knowledge. We don't need to provide it with label. So label is actually the types of knowledge the human gave to the AI model. Let's say you give your knowledge about this image, right? So you tell the model this is the image of the airplane, this is the image of automobile, this is the image of bird. So that is your knowledge. But so we call that a label, right? But in the reinforcement learning, we don't need to do that. The model can figure out the knowledge itself. That's why we expect it can be the door to AGI. So in reinforcement learning, we don't have the label. How the model can be trained? We use another thing. This called reward. And in the reward, um, we don't teach the model to do, and we don't teach the model right or wrong, but we just give it the reward or the punishment. That case very in some nightmare comedy. When you go into that comedy, no one told you what to do. You just do random things, and by the end of the day or the end of the month, they gave you the bonus if you do right things, and they gave you some punishment like they deduct your salary because you do the wrong thing. So that's the types of reinforcement learning. And it's not really effective, right? Yes, it's not really effective in training. It consumes a lot of resource because imagine that way, if you want to be a good staff with no supervisor, then you need to do maybe for many years. But with another lucky staff, he or she have very good supervisor, then he can get a very good start, right? But for the other one, when you don't need to give the model um, your knowledge, then the model it can it can be smart in even the environments that human have no idea. Let's say it go into the moon, it go into the Mars, or it go to the ocean floor where human we don't have much knowledge, right? But it can still figure out what to do there because it not depends on our knowledge. It doesn't need it, right? It can figure out itself. So we just give it the reward. If it do the thing that we think it's good, then we give it the positive reward. If did the bad thing, then we give it the negative reward, right? Like for example, um, you want to train this robot go to this direction, not go to this direction. So you don't tell it, hey robot, let turn right. You don't tell it like that. You just let it go by its like randomly. But if it go to this place, then you give it like minus 100. Okay, so it will learn by itself. This is not a good place to go. Next time, is if go to this place, you give it like 100 points. And the reinforcement learning algorithm is designed to maximize the total reward the agent can get. So it just do the task uh, more and more time, then it will figure out what should be the strategy it should use to maximize the reward it can get. And if you design the reward system properly, if you hi, yeah, if you design the reward system properly, it will encourage the agent to perform better and better, right? Like the KPI system in the company. If it's the good KPI system, like you give the good reward for the people who like who was it, then it will encourage the staff to perform better and better, right? But if not a good KPI system, like you work very hard and you get the same thing with the people don't do anything, then it won't encourage the people to to work well, right? So in reinforcement learning, it's very important to design the proper reward system. And we train the key idea of reinforcement learning is that we use reward system to train the agent. We don't need to use the knowledge. We only need to give it the reward. Okay, and I think that's it. Now let's check with the MCQ, everyone. Which of the following scenarios is the best example of the problem that would be addressed using unsupervised learning? Unsupervised, okay? A, a food tech company predicts a shelf life of a new dairy product. So that's a uh, how long it can be kept on the shelf. For the new dairy products, based on the temperatures, humidities, and other data from the similar products with the non-shelf life. B, an IT security firm uses historical data malware signatures to predict whether some news files is malicious or benign. Is that a virus or not? C, a psychological research team uses AI to group individuals into distinct types based on the survey's responses. And D, none of the above. Okay, so A, B, C, D. Which one is unsupervised learning? Okay, very good. Many students select C, right? Yes, it's E because you can see it's just group and it's no information to group, right? It's just based on the survey response. Um, but for A, we do have the label, right? Non-self-life. So this is the output and we do not it. So this is the label. And here as well, we have from historical data of normal signature. So we do have the label, right? But this one we don't have the label. So it is actually unsupervised learning. Okay, in the last few minutes, I will briefly talk about the neural network. Uh, just a quick questions, everyone. So, uh, actually, we have two sub questions. Questions number one: which wave we are in at the moment of AI? We're in wave one or wave two or wave three of AI, and what is the name of the current wave of AI, everyone? Excellence. Yes, it's a deep learning, and we have with three deep learning, right? We are here. Three deep learning. Like chatbot, ChatGPT, Gemini, VO3, or some other good example you're using nowadays. Most of them, if not all of them, are deep learning. And what is deep learning? Deep learning is the models built on the thing that we call neural network. So this is from, so what you see in here, that is um, neural network. Is actually the biomimetic research inspired by our human brain, right? So in our human brain, we this is the simplified form of a brain cell. So neuron is actually the brain cell, the cell in our brain. We call that neuron. And what you seen is the biological neuron. That is the real neuron in our brain. And in this neuron, we have three key parts. The first part here we call it dendrites. where it gets the input signal from maybe from your sense, from your eyes, your nose, your mouth, or from other neurons. Okay, it gets the input signal. The signal is can be in the form of electricity or some chemical. Okay, some chemicals or some electricity. And when the input signal is go into the dendrites, it get into the place we call the cell body. And the cell body is the place it combine on the signal from the dendrite. Let's say the dendrite it gets signal 1, signal 2, signal 3. Let's say it's in electricity, the signal 1 is zero point 0.1 volt, zero point 0.2 volt. This is 0.05 volt, something like that. And when this electrical signal is go into this cell, the cell body will be the light is combined on the signal, and it will produce another signal. Let's say we produce some signal like 0.15 volt. Okay, so that's the uh, functionality of the cell body. And after it produces the new signal, it will transmit to the thing that we call the terminals, and the terminals is the outputs where the signal this this electricity is will go to the next neuron. And in our brain we have billions of neurons connected together, and we call that the neural network. And here is the example. So the human cortex, the cortex in our brain. So that is the example of the the, the neural network. Cortex is in Vietnamese called vỏ não. Okay, uh, um, so this is you can see here you have many neuron, right? You have many neuron that connected together, and we make the thing. It's make the thing called neural network. And in computer science, we try to mimic that, and we make the thing that we call artificial neuron. So it also have three key spark at the biological neuron. The first part is the input. Second part it is the this is the function. We have some function, and this is the output. Let's say you imagine the artificial neuron, it's just like a function. It gets some input, a 1, a 2, a 3, and it gives some output O. Okay? Or it can be like fx equal to y if you're familiar with this notation. So here's get in some input, and there are some formula it will compile these number together. So in artificial neurons, the input is just a number. Let's say it is 7, 0.5 here, minus 1. Okay, so it get these number in, and it will compile them using some formula like plus or multiplication or something like that, and it will compute, it will out something like uh, 2.4, and this will be the output. It will go to other neuron. And when we compile them, we have the thing that's called artificial neural network. And in the neural network, if we do have so many layers, like let's say here we have only 3 layers, but we can design a bigger neural network, like it have 4 layers, something like this, and 5 layers, something like this, 6 layers. If we have a lot of layers, then this network it become deep. So that's why we have named deep learning, right? So this is actually very shallow. We have only a few layers, but if we do have so many layers, then we have a deep neural network. That's why this field is called deep learning. Okay, so it just I think that's the idea about that. And for the math here, uh, it's optional. Okay, so um, you can check out more online. If I go into this one, maybe we will go over the time quite a lot. And yeah, just for your information to know how, if you are curious how the function, what what the formula look like. Okay, so this part is just about that. We try to write down the formula of that function for you. Okay, but it needs to do several things in math. So for that, I think you can check online. If you want some animation, you can check this link. We do have animation like this one. I can show you quickly this. Okay, so you scroll down here. You will see how a single neuron is compute the signal. So you can see here that it looks like the gatekeeper, right? So this is input, and we call this in the weights. When it get the input, that is a number. So number will be get int, and the way the neuron compute the output is that it will let this weight multiply with the input. So the input here multiply 0.7. This input multiply 0.6. This input multiply 4.1.4. Okay. Now I have a question for you, everyone. Signal 1, signal 2, signal 3. Which signal is become larger after multiply with the weight? Which one become larger? Yeah, only signal 3, right? So the weight here is actually the way to tell which signal importance. So if this neuron is a trend and it think that this signal is more important to the output than the other one, then it will amplify the signal by putting it with the weight greater than 1. For the other one, it's not important, so it put the weight less than 1. Then when it's going to this one, it will become smaller. And then the way they compute next is they will take the summation of all of these multiplication. Then they will make another summation with another number we call the bias, and they put it through the function that we call activation function, something like this. So you can see multiplies become smaller, this one multiplies become bigger, and they will be take the sum and sum with another number, then it's put into another function is called activation function. It will give the output. Okay. Uh, so I think we can stop there. For further information, you can check online. We don't need to go to many detail in this code. Okay. And another one, if you want to build your own neural network, this is a playground from Google. You can also try to build your own network. Let's see here, you have 4 neurons. You can increase the number of neurons. You can increase the number of layers and increase the number of neurons here. And when you dig place, it will train a model. So you can see it can, you know, uh, this will do the classification. It will classify the red dot and the blue dot. It work very well, right? But if you try with this one, it will be harder. You want to classify the red dot and the orange dot and the blue dot is harder, right? So maybe you need to change your model. Let's say I will add more layer. I can add more input, something like this, and it can maybe help me to learn better, right? You can see it takes longer time to learn to run. Maybe we can add more, or maybe we try to remove these things, remove this layer. Let's try. Or I can also change the activation function. Okay, so you can see it's not an easy one, right? But it really try, right? You can see it's successfully classify this part. Okay, you can play at home. Okay, and that's it for this week lectures. Any questions, everyone? Type 0 if you don't have any questions. Okay, many zero there. Okay, so it's just some teasers for next week. You will learn how to build your own machine learning model. Okay, uh, we actually build a machine learning model that can work with AWS tool. And in order to prepare for that, in this week tutorial, you will set up the AWS. and all the instruction will be given in the tutorial. All the material is uploaded in the share folder already. Okay, check it, and if you need any support from us, let us know. Okay, so thank you very much, everyone. See you next time. Enjoy the rest of your day.